Have you guys done a warm up? I wasn't here Monday.
Testing.
Mr. Boss,
Yes.
we have a calculator
Oh, yes.
and also I do this and then Friday Tuesday and Thursday at school. There's one.
Oh, was there one?
What?
I don't think he's going to
Yeah. Yeah. Can't do anything. Mascara, really? Mascara. Like it's just really important.
No, it's just Mr. Martin. That's how he keeps his hair like up.
Hilarious. That's actually not allowed.
What do you mean?
Spider-Man.
I get Batman.
That, yeah, that is my I think you're taking video, must be
Change shit.
so many ways to get this. Almost got carpal tunnel. Yeah, I have.
Negative extra.
I have no idea like what that means.
Can't just draw
You
a
don't know what
reference.
that means. You know what it means? Attention, deficit, hyperactive,
What?
I'm sitting there. I already checked you guys. When we get started.
Come on, mate. It's Friday.
That's pretty good.
I don't know what you're talking about. I just did. What?
No, wait, really? Are you from somewhere else?
Berkeley.
I just did it for fun. Is it pretty convincing?
What?
I think it's bad.
No, it's not convincing. Like, I mean, I'm sorry. It's like, it's really, really, what's it called? Like, after you do it, like, a little, so it's like,
Yeah. 7 more minutes or 6 more minutes.
Finish bad. I think that's being a bit ambitious.
yeah, I don't know, I just put it in.
So what is it? It's a graphic.
But why not use it? No, just, don't use it. Oh, I didn't
If you read the graph, that's X increases with 0. 7. Yeah, that's good. But it comes like a. Would you get for an easy?
Yeah. We asked him if I had any English. We asked him if I had any English. Yeah, I just did it wrong first. I had to redo it.
What do you want me to say?
Do we have English?
Oh, yes, no.
Keep working, keep working.
Yes. And after.
Mr. Mom? Question. Is it time for us to grow?
That's what this session will be.
Smart.
You guys have about like 3 more minutes.
You were married? You never gave us enough time. Really?
What's motivating you to like, I mean, are we going to end it? Mr. Mom? What's motivating us to do? And then are we
So
going
that
to
you'll
end
really
it?
understand.
But I already figured it out. But are we going to end it? Oh, are those actual glasses? My turn. Mr. Mom, do you have a... Oh, yeah, I guess. Do you have a Snapchat? I'm sure you can Snapchat it.
I was like that, man, sure, it's time to go. Yeah, me too. So I should be like, yeah, that's exactly what I meant. Then I wanted to be ready, so I figured out like, I can do my my last year, I tried to I just write as fast and as I signed up. That's how my like, and I did it on the line. Yeah. Or it's like look up. Yeah, no.
No, I think so.
I didn't have it.
Oh, yeah.
Okay.
This space is so.
I know you guys are like. So I know you guys are at various places in the worksheet. We need to move on, so we're gonna go over it really quick. Okay.
It's so much shit. Yeah. Only if you don't have
Okay.
keys, man. Only if you don't have keys.
Okay. So for the first one, did everyone at least do number one? Yeah. Did you grab something like what's up here? Something like
You
that?
can drink from the big mouthpiece.
Yeah. So, can someone tell me what the first question is asking? What? Thomas? Earphones out. What is it? What is it asking?
Well, question.
Now, help us out. The graph. What happens to the graph as x increases from 0?
It starts to increase rapidly.
What was that?
It starts like the angle of the graph, or like the rate increases more.
The rate increases. That's a very good way to put it. So, Mohammed, Reed? So, what did God say about the graph? What did God say about the graph?
I don't really know.
Were you listening now? Okay, so what God said was that the rate of the graph was increasing. The rate at which it increases. Okay, so that's a good way to put it. You can say rate of the graph increasing. How about as x goes from 0 and it decreases?
What's the word for the thing where it's approaches there, but there's no friend there?
Very good. What is that called? Asymptote. You remember that? So I would say that the behavior, as Brem said, it approaches 0, right? An asymptote. So what do you guys think? Is there a maximum? Why not?
Yeah, sure.
Keeps going up, right? Yeah. What about, is there a minimum?
Yes.
Is there a minimum?
Really? There is no minimum, no.
There's no minimum?
Oh,
Why
it
not?
goes on.
It's an asymptote. No minimum.
No, it goes down.
Why not?
Because
Because Brem, why do you think there's no minimum?
yeah, and it always gets closer. That really like
Oh, you're gonna test?
But if you divide by a fraction, you'll always get close to the line, but it won't ever touch.
I've never touched. Yes, okay. That's true too. It'll never, so that's a good observation. It'll never approach, it'll never touch 0, right? It gets really close, but it'll never touch 0. So what I would say is all those are valid, but since it approaches 0, but never actually touches it, there's no actual minimum. For example, if this was 0, and you say that like right here is the minimum, it still continues on lower than that. Does that make sense?
Yeah, it goes on forever, but doesn't really pass.
No matter what point you pick, okay, this is kind of like upper division math stuff in college that we talk about. But think about if this is the minimum that you pick a minimum, right? Because it can't touch 0. There will always be something smaller than it after. So there's nothing. There is no minimum because for any point that you pick, there'll be one smaller.
wow.
Hey,
Does that make sense?
I know what you mean.
That's
Kind of. I mean, if you understand, that's pretty cool.
I know another way of thinking.
A lot of people, a lot of college students don't. What's that?
There's like this one thing where like it was a map from like how long would it take somebody if they took a span of the room and then every like half they shrunk and then just how long would it take to reach it?
Do you guys understand that? There's like this problem that has this room, a square box.
Oh, yeah.
Usually it's like a square. And then if you paint half of it, does it like paint half of it?
I don't know. Yes.
I think it's something like if you paint half of it, how long will it take you to complete the whole room?
And if you keep.
Forever.
Forever, right?
How to keep an idiot waiting?
You'll never reach the last part of it. You'll get close to it, but you'll never reach.
Yeah. Oh, is it one of those?
It's a little bit where like you take one step, you take half a step,
Every
half a
time.
step.
But you'll never reach. What was it?
Small.
Yeah, but technically you'll never finish, right? Okay, what's that?
Because of a round thing, you win. Because it's like
Round
0,
six?
0, 0, 0, 0, 0, 0, 0, you're gonna round it. And then you're gonna wait.
What if you just still mean?
This is a mathematical thing, it's not really like, it's kind of like,
And wipes on all these.
yes. Okay, so let's keep going. Number 2, if you haven't gotten to this point, can you at least graph 5 to the x on your graphing calculator? So what do you guys notice about this one? How is it the same as 2 to the x? Again,
Have the same general shape and share point.
shape, general shape. Okay, yeah. Did you guys all get that? Same general shape, yeah. How are they different though? One was steeper? Yeah. Which one was steeper? 5, right? So what does that say about if I went higher? Like they stay here, 10.
It would be steeper.
10. The 10 to the x, do you guys agree that it would become steeper? Steeper. And then also Ileana mentioned earlier something that they share in common. What's the point? Do you guys all get that? They have a 6 common point. Do you guys get the point? 0.6. 0 and
On the y-axis, y.
okay, let's think about that. So if it's on the y-axis, what value of x are you plugging in? 0, right? So that was a really good point. So you noticed that the common point was on the y-axis? Right? There was another graph that they shared a point on the y-axis, right? This point means that the x value is 0 right here, right? So if I plug in 0 into any function that looks like this, what do I get? 1. So does that make sense why they all have that point in common? They all have 0, 1 as a point. That makes sense, okay?
Yeah.
Sure.
Because they go to 0 power.
0 power is equal. Yep. Okay. Next, did you guys? Okay, so hopefully you guys can get this part, but this is what the graphs look like.
What?
This is what the graphs look like. I said talk to you guys.
You look just good at that.
So Zoe drew her graph here. This is what.
We're wrong.
So this is what the graphs look like. Here's the original one, y equals 2 to the x. The second one here is y equals 2 to the negative x. Can someone tell me how they're related? Reflections, very good. Reflections about reflections y-axis. Which one's x? Which one's y?
I forgot the graph.
about the y-axis?
Yeah.
Yeah?
Yes.
Okay, so why do you think that happens? Does anyone have an idea? So we changed from x to negative x, right? Can you think of an example where that, like,
Well, the x values are going to be the opposite, so it's going to go the opposite.
exactly, yeah. So what Bremso was that, like say if you plug in 1, 2, and 3, if you make that negative, so say if you plug negative 1, 0, 1 into 2 to the x, yeah? Then you get, yeah, 2 to the negative 1, 2 to the 0, 2 to the 1, right? But if you plug it into 2 to the negative x with these values, it becomes positive, right? So you get 2 to the 1, again you get 2 to 0, but you get 2 to the negative 1 afterwards. So they switch. Another example of that, if you think about the graph y equals x. What does that look like? What is that? The graph of? Y equals x. Y equals x is just a line, right? Y equals negative x is a line going the opposite way. Does that kind of make sense? So instead of having our exponential function like this, it switches, it reflects like this. Kind of see it? Okay. And then for those of you that got to the last one, 1/2 to the x, what did you notice?
It's the same as
It's the same as
2 to the power negative x.
2 to the negative x? So 2 to the negative x was apparently the same as 1/2 x. Why do you guys think that's the case? Think about what you know about exponents, your properties of exponents. You guys? So, do you guys remember your properties of exponents?
Yeah.
So what Emma said was that you can make this a fraction, right? With your negative exponents, you can bring it to the denominator. Right? This equals 1/2 to the x. Yeah? Which is the same as 1 to the x, 2 to the x, right? Because 1 to any power is just 1, right? So I can still say that these are equal. Therefore, 1/2 to the x is the same as 2 to the x.
Oh.
So remember your properties of exponents. Okay. That this you can break down to the denominator. Following this logic, you can get that these are the same. Response? Okay. Does everyone have any questions about what we did so far? Okay. So take out your homework one more time. Really quick, does anyone have any questions about what we did? Yeah. Lot more? There's no graph. Oh, you have the graph one? I think you just have to fill out the chart.
What is it? Oh.
So, you guys should be checking your homework. Do you have your homework? Were there any problems that you guys had trouble with?
7 through 11.
7 through 11?
7 to 11?
3 is 625, right? Not 624.
Wait, what was that?
Number 3 should be 625, shouldn't it?
Oh, yes, right. 7 through 11?
But they're all, I have like the same problem with all.
Of course.
So-
It's the same, yes, same problem. Okay. Did anyone else have trouble with the problem? Okay, really quick. So let's look at number 7. numbers. So this is kind of a matter of knowing how these numbers are related with. So number 7 says, write the following in base 2. So that means I want to find something, some exponent, where 2 to that exponent would equal 128. What do you think that one is? You have any idea? What's that? 7.
But is it like, how many times can two go to power?
Kind of. Okay, so what we're doing here, again, we want to know for what value of x, if we take it to 2 to the power of x, will equal 128. Daniel said 7. Does that make sense? That's 2 to the 7. 2 to the 7 equals 128. Okay. So let's try a little harder. One that's a little harder. 16 to the 16 to the power of x. How would I put that in base 2? 2 to the 4x. You kind of see why that happens? So think about this as 16 to the x, and 16 to the x is just what? 2 to the 4th, right? 2 to the 4th to the power of x. Therefore, it's 2 to the 4x. Make sense now? Okay. So now I'm going to start with notes. So
What are names?
take out your notes. We're starting the new section, 9.1a, exploring exponential functions. Does everyone have their notes up? On, Luis. Yes, help me. So our goal for today is to our goal for today is to first know what an exponential function is and learn the properties. We've already kind of seen some of them from the worksheet. Okay. So does everyone understand?
Yeah.
So let's go over the definition. Exploring exponential functions. Okay, so the definition of an exponential function. An exponential function is defined by the equation y equals a times b to the x. Okay. So any function that you see in this book is considered an exponential function. So an exponential function is defined by the equation y equals a b to the x. So does that kind of look like the equations you're working with in your worksheet? Is it a little bit different? No? Not at all? The same? to what? It has A and B, right? So in the cases that you've been working with, A is equal to 1. Right? Does that make sense? So it can be something different. So how is this different from the exponents we've been working with so far?
You added the negative.
That's true. That's something different that we've done. So, yeah. Anyone have any other ideas? So we've been working. What's that?
Graphing.
We graph number 4. Yeah. Yeah, the graph is. So think about, okay, this is what an exponential is, right? But the exponents that we've been working with so far are like x to the n. How are they kind of different? But it could be a to the n. So it's not exactly the same. Think about what you're plugging in. Ingrid.
Is that X is the
Exactly. So our variable in the exponents that we're working with is the base, right? So the variable that you plug in for the exponents we used to work with was the base. But now the variable is the exponent. You see that? The constant term was the exponent before. Now the constant is the base. So it's kind of switched. So now we're going to get into some of the properties. So there were two, out of the graphs you saw, there were two different graphs, right? They were kind of similar, but they were different. Can someone show me with their arms? The two different graphs? Basically what both do, right? It's kind of doing like this. It's referring to like the graphs that are like this and the one that was reflected, right? You mentioned earlier. What was different about those graphs? What's different about the equations of those graphs? Explore. That's true. They had opposite signs, right? But then what?
They're also reciprocal.
Reciprocals, right? So remember that the graphs that look like, is it this way for you guys? The graphs that look like this were 2 to the x, 5 to the x, 10 to the x, right? And the graphs that look like this was 1/2 to the x, right? So do you think there's a difference between what value you plug in as the base? Like what was different about the base in those bases? So remember the graphs that look like this, where 2 to the x, 5 to the x, 10 to the x, and the graph that look like this was 1/2 to the x. How would you say they're different equations? That was one thing. So the negative exponent, the thing about the negative exponent is not always going to be, will not always be a graph like this. The two equations there. That's, yeah, kind of.
One's less than one, no. Yeah. One's less than one, yeah.
Do you guys hear that? Can you say that one time, Dave?
One is less than one, and then
One is less than one, and these are greater than one. That's how they're different. So think about what you're doing when you're doing exponential functions, right? Like if you have 1, you're multiplying your original by 2. Okay. And if you take it to the second power, you're multiplying by 2 again. So what you're doing is continually multiplying by your base.
so if you this less than one, it's going to go down, and then it's going to go next.
What's that? Will it decrease?
Only with like negative.
What's that?
It will only like increase with negative.
Or if the base is less than 1. Okay. So think about this really quick. 2 to the x. Okay. At 1, it's 2. At 2, it's 4. You're constantly multiplying by 2. Right? That base. Each step you go farther, you're multiplying by that base. So if your base is less than 1, you multiply by half, half again, half again, half again. Decreases. Does that make sense? So yeah, so for b, if b, the base, is greater than 1, the graph increases left to right. And if b is between 0 and 1, is that how you're taking notes? Is that how you're taking notes?
Yeah.
Tomas? Take it. Okay, so for b in between 0 and 1, then it will decrease. Yes. If it's negative, it becomes the opposite of both.
Alright.
And then we also said earlier the common point is 0, 1.
Is it
Oh, exponential.
because the x value could be 0.
0 to any power. 0 to any power is 1. Okay, really quick. Last property.
What's the
Common point is 0, 1. Okay, last property, last one. B to the x equal 9, b to the y implies that this means implied. Okay, this double arrow, double bar arrow is implied. Implies that x equals 1.
You want me?
Does that kind of make sense to you guys?
read the equation?
Read the equation. B to the x equal b to the y. It implies that x equals 1. Is there any question about what that means? So for example, if I have 2 to the third power equals 2 to the x, what can x be? I am Melissa. So if I have 2 to the third power equal to 2 to the x, what can x be? 3. Can it be anything else? No. Does that, you understand what that means? So therefore, x equals 3. You understand the example?
Sorry, I don't remember.
If I have something with the base 2 and they're equal, right? Then the exponents have to be equal. X cannot be anything other than 3. So really quick example.
It sucks when it's
you understand, that's cool. So let's try 98 here. So, like the homework last night, how can I write these with the same base? With the same base. This is the base, right? I would want to use 2, right? So 2 to the x equals 2 to the third, like I wrote up here. So therefore x must equal. Good. Does that make sense? Okay, here's another example.
Wait,
What's that?
this looks like the thing in my favorite. Is this like vlogs
We're getting into it. That's this chapter.
Oh.
So next example, 64 equals 8x minus 2. Then, you need a glass of water to take?
Good. He's like this funny.
Okay, so right here, how can I get a similar base? What would I want to use as my base? 2? So would 4 to any power equal 8?
Not how I calculate
2, right? So what is 64 to in base 2? With the base 2, what exponent would you use for 64? 8? 4?
I mean, X is 4.
Yeah, that's us.
It's 6.
Yeah.
Good. First, okay, so my question, one second. My question is, what exponent would you raise the power 2 to get 64? And 6. 2 to the 6th power equals 64.
Why do you use 2?
Because that's the base that they just put shit.
That's the lowest. The lowest base there.
What base would you suggest otherwise? 4? 4 to what power equals 8? 4 to the power 4 equals 8. I want to write 8 in the power of 2. 2 to the third, right? So remember that this is 2 to the third to the x minus 2. Therefore, it's 2 to the 6th. What do I do to these exponents? Multiply them. Multiply them, right? So I have 3x minus 6. Is that okay? Yeah. So therefore, again, by this last property, the exponents are equal. So that means 6 equals 3x minus 6. And then we can just solve. So we got 12 equals 3x, therefore x equals.
Great.
Yeah,
That's definitely.
What's that?
This doesn't make sense. Never mind.
Does this make sense? Does it? Okay. Let's go over one more example. 9x to the 2. 9 to the power x minus 2 equals 27. What base do they share? 3, right? Guys, let's focus. So the base that they share is 3, right? So how would I write 9 in base 3? 3 to the second, right? 3 to the second to the power x minus 2. And here I would write,
rewrite it.
to what power is it? 4? Third? Third, yeah. 3 to the third power equals 27.
7.
So if I were to, what do I want to do with these exponents?
So we got
How do I know what x is? So remember the property. After I distribute this, okay, we know that we multiply, right? So I have 3 to the 2x minus 4 equals 3. And the last property said if b to the x power of x equals b to the power of y, x equals y. The two exponents are equal. I can't tell anything from it.
Yeah, no.
You can't tell anything.
I can't tell if you understand what
Oh, I
I'm saying.
don't.
Oh, okay. So if you have exponents of the same base to the power, different powers, and they're equal, then the exponents are equal.
Oh. B and B.
If they're at the same base. So the exponents in this case were 2x minus 4 equals 3. And we solve it by algebra. So I have plus 4, right? 2x equals 7, x equals 7 over 2.
Can you write it as a decimal?
What's that? You can write it as a decimal.
It's confusing, but it's not.
All right.
How do you guys feel about that?
It's good.
Yeah.
Yeah, 'cause this little, like,
Solved it.
How to solve?
No, I understand it better.
So can someone, let's see, Mohammed, do you tell me one thing you learned today?
Sure. Oh, you gotta have the basic equal to each other.
Bases equal to each other? Okay. For this type of problem, right?
Yeah. So the base, only if the base is like x.
Yes.
No, I know.
So what's one thing you learned? Guys, class isn't over yet.
Yeah, that's mine.
Melissa, Anya? What's one thing you learned today?
One what?
Anything. What's something you learned today?
Oh, but it's something at the same base, but their exponents are equal.
Okay. That's good. That's kind of what Mohammed said also. What about, go ahead, Brett.
if the coefficients of two functions are equal to each other, then that will be opposite.
Yes. Yes. And it's also the case when the exponents are different signs. What do you learn? Exponential function? Okay, so today your homework is different from the stamp sheet. It's right it's up here.
Yeah.
So I would suggest taking out your stamp sheet, copying the stamp.
You want to turn in this worksheet? Work on it.
Yeah.
No, this is pretty easy.
So if you have a calculator,